Hello everyone, welcome back to Arduino and My Robot. This is chapter 16. In this chapter, we'll be learning about an important component that's called as ultrasonic sensors. What is an ultrasonic sensor? An ultrasonic sensor is an electromagnetic device that measures the distance of a target object by emitting ultrasonic sound waves and converts the refracted sound into an electrical signal. Now you can see in this first right side top photo, there is a bat that is using ultrasonic wave. First thing that you should understand that these ultrasonic waves are not audible to human ears. Human ear is capable enough to understand or hear those sounds or recognize those sounds which lie in between 20 hertz to 20,000 hertz. So hertz is a unit for frequency. Frequency you can understand as the number of time anything is happening in a given time period. Suppose if you are eating your lunch or food 3 times a day, so I can say your frequency is 3 in a day. Similarly, in hertz means number of times a signal is going up and down. It is making one complete wave. Number of time it is going in 1 second. That unit is called as hertz. So human can understand if the frequency lies between 20 hertz to 20,000 hertz. But if it is beyond 20,000 hertz, it is called as ultrasonic waves. Now you see this yellow line, that is our bat. Bat is emitting ultrasonic sound. What it is doing is it is making some sound from its mouth. Okay. Now we cannot hear it because we are not capable enough to hear the ultrasonic waves. So what is happening is this bat is sending the signal. Okay, it is making some sound from its mouth. Now it is going and getting strike means this insect is in its path. So when it goes and to this insect, it starts coming back like it's like echo. Okay, so you see the red mark, it's a returning sound wave. When it comes and it strikes on the insect, it gets bounced back and it comes back. Okay. Now what is happening is this bat now knows that there is something in its path, the sound wave path. That is why he is getting back an echo. Echo is a sound that is coming back. Okay. If you remember or if you have ever tried, if you go into an empty hall and shout, you can hear an echo. Same is you can hear an echo of your own voice when you shout on the mountains. Okay. So what is happening is the signals from your mouth or the sound waves from your mouth is going and getting reverted back from the mountains or the trees or any other obstacle it is getting and striking on those things. Okay. So what the bat is doing is giving a signal out, a sound wave. It goes and gets touched by this insect. Then it comes back. Okay. It comes back and now the bat can receive it. First it is sending, then receiving. So it is a two-way working process. First you have to send the signal, then you have to receive the signal. So when it received the signal, that means there was something, some object was in the path of the sound. If it does not receive any return wave or echo back, it's not giving any echo in the back side, means it is not returning any sound. That means the path is clear. Okay. Same concept is used by dolphins when it is going for fishing. So it will make some sound from its mouth and it will go and strike with the smaller fishes or the bigger fishes. And it comes back, the sound wave comes back. And by that, dolphin can recognize, okay, there is some fish ahead of it at 100 meter or 200 meter or 300 or 1 kilometers. Okay. And by that way, it will know, okay, I have fish in that direction. I can go and eat in that direction. This same principle was utilized by submarines. Submarines are ships that are running underwater. Okay. So what they do is they also give out the sound waves, and this sound waves, when they strike to some other ship, it comes back. By that way, they can actually locate. This is called as echolocation. This process, which you can see, it is creating an echo and by echo, it is finding the location. So this is echolocation. So this principle is used by ultrasonic sensors. So here is a sensor. It has 4 pins. Okay. So first pin is voltage pin, input pin from where it is going to get the current. Then we have trigger pin and echo pin. Okay. You see, this is a trigger pin and this is an echo pin. So one is to send the signal and other one is to receive the signal. And the next pin is ground pin, because every component should be connected to ground so that any extra current in it will be flowing to ground and it will prevent the circuit. Just for your general knowledge or information, speed of the light is 3 into 10 to the power 8 meter per second. And when you compare sound speed with respect to that, it's just 343 meter per second. There is a general formula that is called as speed is equals to distance upon time. Now, why this formula? Suppose if I want to find the distance, at what distance our prey is. Suppose at what distance these fish are. So the distance from here, from its mouth to fish, it is D. Let's suppose it is D. But for the sound wave, it is going here D, then it is coming back. Okay, so the sound wave has to travel how much distance? 2D. That's why I have written here 2D. One trigger pin is sending the signal and echo pin is receiving the signal. And in that duration, I have covered how much of distance? 2D. Now I know the sound. I know the time in which time I'm receiving. Suppose I have sent 1 second back and I've received it. I know the time between how many seconds I'm receiving it back, and I know the speed of the sound. So I can calculate at what distance the object is. Okay. Whatever the distance is, that will be 2D. I'll be dividing it by 2, and then I can find what is the distance of the object that is in front of the sensor. And one thing that you must remember is whenever the trigger pin is on, that whenever you send the signal, the echo pin that is receiving end is off. When sending end is on, receiving is off. When receiving is on, sending is off, because it is done to prevent any kind of overlapping. Okay. So now let's go back to Tinkercad and see the project. Okay, we'll do it in next video. Thank you for this.